is there on the surface, and what are the different forms of ruthenium, whether it is in the ionic form or it is in the metallic form. If it is in the ionic form, is there oxide present, and if oxide is there, how much it is. So once we do all these things, then we started with the reaction. So this is the reaction that we do. So here again, for the first test, we don't take the lignin directly. We again make sure that, okay, let us start with the glycol again and try to see where we are getting the best result. So we were getting, if you see in conversion, maximum 79% was attained in 24 hours, and in this case our product toluene is formed, and that selectivity for toluene is 98%. So we are getting hydrocarbon, very good. So now we started with the real lignin. That was the first task that we really need to see. So here we performed the reaction. We isolated the lignin from the corn cob and also from pinus, and then we identify the product. So we get phenol. This is another phenolic compound. So if you see, most of them are phenolic compounds, and there are few long chain hydrocarbons, but still oxygen is not completely gone and ester moieties were still present there. But somehow we were able to depolymerize the lignin, simplify those lignin fragments into the phenolic compounds, and in some cases, if you see the next one, even the hydrocarbon toluene was also isolated. Though the yield was not that much high, it is just a 10%, but still it is directly getting, we are able to get this toluene directly from the lignin isolated from the plants. So I think I have time, Dr. Kuldeep, approximately half an hour or 15 minutes? Okay. I'll try to sum up it in 15 minutes. So now the question arises that how we identify these products. So we use the technique we call that LC mass. So here I'll give you a brief, because most of you are master students, so let me explain this technique to you. In this technique, do you know about chromatography, students? So what we do in chromatography? Separation based on polarity. Right? So we are taking paper chromatography is the simplest example that we do from +2 onward, right? So we are taking a paper support and move a molecule on it, and it gets separated based upon its polarity, right? So that is exactly what we are doing in LC mass technique. It is also, we have a column filled with a support, for example silica, and then we are passing the compounds through a solvent, and then they get separated. और टैप की तरह आप इमेजिन कर सकते हो कि कॉलम के एंड पे एक टैप है और उस टैप से वो अलग अलग आते हैं, और उसे हम एक इंस्ट्रूमेंट से एनालाइज करते हैं जिसे हम बोलते हैं मास स्पेक्ट्रोमीटर. आपने स्पेक्ट्रोस्कोपी में पढ़ा होगा. वो हर एक का अलग अलग फ्रेगमेंट देता है कि भाई इसका मास इतना है, इसका मास इतना है. तो हमने यही चीज एनालाइज की, एंड दिस इज हाउ वी आइडेंटिफाई दीज प्रोडक्ट्स, एंड दिस इज द रिलेटिव पोजीशन ऑफ दोज प्रोडक्ट्स दैट वी आइडेंटिफाइड थ्रू द स्टैंडर्ड लाइब्रेरी इन LC mass. And that is how we make our report. The final task was that, can you use your catalyst multiple times? We say yes. I have used this catalyst, I do the reaction, I separate it, I recover it, right? So separation is a little bit tedious, because if you filter it, lignin, unused lignin get mixed with this. So what we do, we centrifuge it, decant it, so that most of the lignin is gone. And in the bottom the catalyst is always there, so we add some more solvent, keep on decanting